So here we begin with test 2 material, and test 2 material is just test 1 material. So at this point, you should probably stop and look at your test 1 if you've gotten it back. I'm going to get it back pretty quickly and see what you missed, because you really do have to know section 6.1 and 6.2 before you continue, because really all we're going to do now in 6.3b is plug numbers in for x to our antiderivative, and then in 6.4 and 6.5 we'll set up the definite integral and then plug in numbers. But let's talk about what that looks like. So this is the definite integral 6.3b. Okay, so here we go. I got a new pen, so maybe this will be better. Six point 3b, the definite integral. And I'm going to go ahead and give you the definition. This is called the fundamental theorem of calculus, so you know it's important. And of course, I'm not going to ask you definitions, but I just want you to know that this is the name of what we're about to do. So it's pretty important. All right, so if a function y is equal to f of x, it's continuous on the interval AB, and capital F of x is any antiderivative of f of x. And capital F of x is any antiderivative of little f of x. Okay. Then we can say the integral from a to b of f of x dx, okay, is the antiderivative, capital F of x, and we're going to evaluate it from a to b. So that's going to be, we're going to plug our top number in for x, then we're going to plug our bottom number in for x. Okay, so this f of x right here is the antiderivative, and we're going to just use 6.1 and 6.2 rules. We'll use our 4 basic rules, and then we'll use substitution. And the thing about 6.3b is they don't tell you when to use substitution, so we'll have to talk a little bit about that. Okay, so that's what I'm going to do. Now what's going to look different is that this A and B, like this is A and B, they're talking about this on x-axis from A to B. A is always smaller than B, and this is a continuous function on that interval, meaning there are no breaks or anything. So if we have that, you can find the integral from A to B. And a little later, we'll find out that actually we're going to be looking at the area bounded by the curve in the x-axis. So that just gives you an idea of where we're going. But for now, we're just plugging in numbers. Okay, so let's do a couple of examples. And in talking to some of you this morning, I think maybe working out the practice problems on video just is a long thing to watch. So this morning I worked out the practice problems for 6.1, 6.2, 6.3b, 6.4, and 6.5, and I worked them out step by step and posted them on Blackboard. So you might like having those worked out rather than watching me work them on a video, but you've got to let me know. Okay, so let's start with them. From -1 to 2, this is what a problem looks like. Let's see, 6x squared minus 4x plus 2 dx. Okay, so we're going to find the indefinite integral. So with this is what this looks like, the integral from a to b of f of x dx. We're going to find the antiderivative using either 6.1 or 6.2, and then we're going to take b and plug in for x, and we're going to take a and plug in for x, and we're going to subtract them. Okay, this really will be a calculator test. So let's find the antiderivative. Okay, so capital F of x is, now remember, this is going to be rule 2 because we just add 1 to it, minus, and then this is also rule 2 because we just add 1 to the understood 1 exponent, and this is rule 1, so plus 2x plus c. So if I just write my antiderivative, sometimes we simplify it, sometimes we don't. 2x cubed minus 2x squared plus 2x plus c. And what we have to do is evaluate from -1 to 2. Okay, so this is where I'm really going to want you to use your calculator. But let's do this. We're going to plug in, always it's the top first. So I'm going to take 2 and I'm going to plug it in for x. Okay. And so if I do that, 2 times 8, see, this is what I really don't want you to do, is to go 2 times 2 cubed minus 2 times 2 squared plus 2 times 2 plus c, because later that just gets really, really messy, okay? And you could, of course, in your calculator, say, what are we doing? We're plugging in the 2 for x, and you could say 2, and every time you plug it in, use a parenthesis, 2 to the third minus, oops, and you have to come down, and then minus 2 times 2 squared, 2 squared, plus 2 times 2. And that's one way to do it, but that's still full of errors too. So we got 12. All right. So that's f of 2 minus, and then we're going to do f of 1, f of -1. Okay. So let's see what we get. So 12 plus c minus, and then if I plug in -1, I get 2. You want to see how I'm plugging it in? I don't know if that looks kind of bright. It looks kind of dark. Hang on. Let's see if that helps at all. I just want you to be able to see the calculator. There you go. All right, so it's 2 parenthesis -1. And if you don't use a parenthesis, it's to the third power, and you have to come down, minus 2 parenthesis -1 squared. You can just use your squared button, plus 2 times -1. And then I get -6. So that's minus -6 plus c. But remember, it's the top minus the bottom. So we have to take this parenthesis and distribute it through. So I get 12 plus c plus 6 minus c. So when I combine all my terms, what's 12 plus 6? It's 18. What's plus c minus c? Well, it goes away. And so every time we work a definite integral that has numbers on the top and bottom, our c will always subtract away, and we'll just get a number for our answer. Okay. All right, and that's really it. That's all we're going to do. But I'm going to work some different examples, and I'm going to show you how to use your calculator. So that's the fundamental theorem of calculus. All right, so let's just look at this same example, since you have it written down and you don't have to write, and you can just watch me. So I was here, my antiderivative, 2x cubed minus 2x squared plus 2x plus c, from -1 to 2. Okay, so I've got to find f of 2 minus f of -1. So here's what I would do. Okay, all right. So this is really important. I do my top number first. Okay, so can y'all see my calculator? All right, so I'm going to plug 2 in for x. So I do 2, and then I store it. I come over here and I store it. It's right beside the 1, and I move up 1. That's my x button. It has I'm going to store it for x, and then I enter. Okay, so it says 2 arrow x. And all I have to do is type in my antiderivative, and this is my x button right here. On a graphing calculator, it's like up here somewhere. Okay, but you can still do it. So if I do 2x to the third, and I come down from my exponent, and minus 2x squared, and then plus 2x, and I can't put my plus c in there, and I push enter, and I get 12. So it took out all this parentheses stuff and plugging and chugging. This is where people make the big mistake. So I'm gonna let my calculator do that. And look how great this is. So now what do I have to do? I have to put -1 in for x. I already have my antiderivative there. So look, I'm gonna say -1, and I'm gonna store that. I push the store button, it makes an arrow for x. And then I'm going to push enter. So I've got 1 in my calculator, and I can use this button right here. This moves the highlighter. So look, I'm going to just move it. I'm going to keep moving it up. And you see how I highlight my antiderivative? So I push enter, and I push enter again, and that gives me -6. So I get -6 plus c. So we already talked about the c's going away. So this example, you really wouldn't have to, but look, I'm going to go up, and I'm going to highlight my 12 that I found before. This keeps me from writing things down. There it was. Highlight the 12, minus, and then I go up and I highlight my 12, enter, okay, minus, and I go up and I highlight my -6, and I push enter, enter, and I get 18. So I just let all my calculator do all the work. And that's what I'm going to do. So, okay, so that's what I'm going to do. All right, so we're going to work some examples, and that's what we're going to do every time. So basically, you just have to learn how to use your calculator. And they talk about leaving your answer. Let's do from 3 to 4 of 3x to the 4th power dx. Okay, so I'm going to find the antiderivative first, all right? And so this antiderivative is going to be a 6.1, rule 2. So I'm going to bring my constant over, add 1, and divide by 5. And since the plus c is going away, I'm just going to kind of forget about it, okay? All right, because the plus c will always go away. So that's f of 4 minus f of 3. Okay, so here I go. I know that you could do that in your calculator, but I just want to get started showing you how to do it. Okay, so so if I clear it out, I want to store the 4. So I'll write it out. I'm going to do 4 and then this STO button and then my X button, and I'm going to push enter. Okay, and get this number. All right, so let's do it. 4, store for x, and enter. And then I'm going to type in the antiderivative. 3 x to the 5th. You could do 3x to the 5th over 5. I just like to do 3 divided by 5 x. There's your caret button up here to the 5th. And I push enter. And I got 614.4 minus, and then I'm going to put 3 into my calculator. So I'm going to do 3 store for x and enter. Okay, so I'm going to do 3 store for x, store, and x is right above it, enter, and I'm going to go up and I'm going to highlight my antiderivative, which is 3x to the 5th, and I'll push enter, and it blanks right beside it, and then when I push enter again, it gives me the value 145.8. Okay, so remember how lazy I am. Now I have to do 614.4, so I go highlight that, minus 614.4. I highlight that and push enter, minus, and I go up and I grab that 145.6 and I push enter twice, and it gets 468.6, and that's my answer. Okay, I do want to show you this. The computer says always write the exact answer or round your answer to 2 decimals if necessary. Well, that just gave us 1, so that would be an okay answer. But how would I turn that answer into a fraction? If you make a fraction, and then in 6.5 and some of 6.4, they don't even take fractions. I mean decimals, so you have to leave it as a fraction. So, okay, so let's do that. See, I have that 468 on my calculator, 0.6. Now this button right above the enter, this double triangle button, if I push that button, it makes an automatic fraction. So I can go back and forth with that. Let me see. So it's hard to see. So that is 2343 over 5. Now, if you write that answer, then you can't make a rounding error, 243 over 5. And if you double arrow it again, you get your decimal, 468.6. So it's up to you, whatever, you know, this is, I would encourage you to really use your calculator, because that's what I'm going to do. Okay, so we're going to work some examples, and I have the problems worked out on Blackboard. And I think that's going to be better than me working them live. But if you want me to work the practice problems live, I'll be happy to do that. So the integral from 2 to 3 of -7 over x squared dx. Okay. All right. So before I can apply my rules, I've got to move my variable term up. So I'm going to rewrite this as the integral from 2 to 3 of -7x to the -2 dx. Okay, so this is a 6.1 because there's no quantity to a power, and it's rule 2. My exponent is anything other than -1. So here I go. I'm going to bring my -7 over, add 1 to my exponent. My new exponent is -1, and I divide by -1. There's my plus c. So you can leave it as -7 over -1, or just call it 7x to the -1. And I'm going to evaluate it from 2 to 3. Okay. All right. So a lot of times, let me just tell you that people see this -1 exponent and think, oh, that's the ln, that's the ln. But remember, this is the answer. This is not the question. AWNSER. AN. Answer, ANSWER. Okay, this is the answer. It's not the question. If we were integrating -1, we would turn it into the ln. It would become the ln, but we're integrating the -2 exponent, and my answer is -1. All right, so when I evaluate f of 3 minus f of 2, I'm just going to practice showing you the calculator steps. So it would be clear it out. I do the top number first, 3 store for x, and enter. And I type in 7x to the -1. And there, 7x to the -1. And I enter, and I get 7/3 minus, and then I do my 2 and store for x and enter. And then I go up and I highlight my antiderivative again. There it is, 7x to the -1. And I push enter twice and I get 7/2. Now, what I love about this calculator, this is really the best part to me, is that when I subtract 7/3 minus 7/2, I can just go highlight my 7/3 with this round button. There it is. And I push enter, minus, and I go up and I highlight my 7/2. And I push enter. And I push enter again, and it gives me -7/6. And that's the answer. If it makes a fraction, it won't always make a fraction, because if it's irrational, it will make a fraction, then we definitely put the decimal approximation. I just want to make sure y'all can see that. Okay, so -7/6. Okay, so most of the the order of the practice problems is all of them are 6.1, and then they do 6.2, but you really do have to be able to recognize 6.1 and 6.2. So let's do a couple of these. The integral from 2 to 8, -3 square roots of x dx. Okay. All right, so here we go. I need to rewrite that. All my variables are up, so I don't need to rewrite that. That's the integral from 2 to 8 and -3x to the 1/2 dx. So it's a 6.1 problem. I'm going to bring my -3 over, okay? And then I add 1 to my exponent. And what is my new exponent? 3/2. And you can do that on your calculator, and then you divide by 3/2, -3 divided by 3/2, or you invert and multiply by 2/3. And so my antiderivative is just going to be -2x to the 3/2. Now, if you want to say -3 divided by parenthesis 3 divided by 2, I mean, you get your -2 that way. You just have to figure out what you want to do. I just invert and multiply because it makes it easier, and I see the 3's canceled and I was left with -2. You could call it -6/3. It doesn't matter. You don't ever have to simplify. But this is from 2 to 8, so I'm going to do my f of 8 minus f of 2. Always top minus bottom. So I'm going to do 8, store for x, and enter. Clear this out. And I'm going to type in my antiderivative, which is -2x to the caret button, 3 divided by 2. And I push enter. And the double arrow button, that will not make a fraction because it's an irrational number. It's a square root. So it says round to 2 decimal places, but I'm going to write it down a little bit bigger and round at the end. But I'm going to show you something really awesome about this calculator. Okay. So I get that number, 45.2548. And then I do 2, store for x, and enter. And then I go up and I highlight my antiderivative. And there it is, -2x to the 3/2. And I push enter. And I get -5.657, let's say. Okay, so I round to 2 decimal places. But look, I don't want to write all that in or type all that in my calculator. So what I do is I go up and I grab that -45.2 number. I highlight it, I go find it, there it is, and I push enter, and then I say minus, and then I go up and grab that -5 number. Then I push enter, and it subtracts them. So I know it's -39.597. And if I'm rounding to 2 decimal places, that's going to be -39.60. Okay, so I only round to 2 at the end. So that's how to do. When you can't do a fraction, you round it, but you wait to the end and round it, and you go grab your decimals with your calculator because it's just too easy to write down a number wrong or make a mistake. Okay, so let's do the integral from 1 to 2, or 3 over the cubed root of x. Okay, so I have to bring that x up. Remember, that's 3 over x to the 1/3. So when I move that up, it becomes the integral from 1 to 2 of 3x to the -1/3. When we move it up, we just change the sign of the exponent. All right, so now this is a 6.1. This is rule 2. I just have to add 1. I bring my constant term over. When I add 1 to -1/3, I get 2/3. I divide by 2/3, or I multiply by 3 over 2. There's my plus c, but I kind of forget about it. So my antiderivative is 9/2 x to the 2/3. And I'm going to evaluate it from 1 to 2. So it's always top minus bottom. So here I go, and I make my parentheses. So I'm going to do 2, store for x, and enter. Clear. 2, store for x and enter. I'm going to type in my antiderivative, 9 divided by 2, x to the 2 divided by 3, and enter, and I get 7.1433. I do 1, store for x and enter, and I go up and I highlight my antiderivative, and I push enter twice, and I get 4.5. And me being the lazy person that I am, I just go up and I highlight that 7.143 number. Well, you don't make rounding errors. You push enter, minus, and we go get that 4.5 and push enter twice, and you get 2.643. So rounded to 2 decimal places is just going to be 2.64, and that's my answer. Okay. All right, so let's just try a couple with the E or an LN. And just to make sure you know how to put those in your calculator. So the integral from 9 to 14 of 2 over x dx. All right, so I've got an x in the bottom, so I'm going to rewrite this, the integral from 9 to 14, and there's an understood 1 there, so that's 2x to the negative 1 dx. And so I don't really think about what I'm doing. I always just try to add 1 to the exponent, and when I do that, I get that 0, and I know I can't divide by 0, so that tells me I have to use rule 3, okay, my LN rule, rule 3, because you still have your rules. I posted them on Blackboard. When you have the exponent -1, you bring your constant over and call it the LN of your variable term. So that's going to be 2 ln of the absolute value of x from 9 to 14. So I'm going to do f of 14. I'm going to do this in 2 different ways. I'm going to do this using the rounding. I'm going to make a decimal and show you the exact, because I think if they give you the answer, they give you the exact. I just want to show you how they get that. You can totally use the decimal. So f of 14 minus f of 9. So I'm going to do my 14, store for x, and enter. Okay, and then I'm going to type in 2 ln of x. But no, the calculator doesn't have an absolute value bar. It just has a parenthesis, which is absolutely fine. So it's 2, and then the ln is just the third down from the left. There's a log, make sure you use the ln. The ln, they open up the parenthesis, so you put your x in and close the parenthesis. And you push enter, and that is 5.278 minus, and then I'm going to do 9, store for x, and enter, and go highlight my antiderivative, push enter twice, and I get 3.394. So I go up and I highlight my 5.278 minus, I go up and highlight my 4.3, and I wrote it as 3.3. So see, enter, and then I get 0.88366, but they wanted to round to 2 decimals, so 0.88 with the 3, which is going to be 0.88. Okay, and you can totally put that answer, and you don't have to worry about this exact, but I just want to show you if they give you the answer, because they tell you in your directions to leave it in exact form or rounded. This is the rounded form. If you leave it in the exact form, you're putting the 14 in for x. So f of 14 minus f of 9, you would say 2 ln of 14 minus 2 ln of 9, right? Because you're putting in the 14 for x, and then you're putting in the 9 for x. And you can type that in just like that. But what you cannot do is say, well, 14 minus 9 is 5. It is not equal to 2 ln of 5. Okay, so that's where a lot of the mistakes come in. Okay, it's like you can't subtract 2 different arguments of the ln. So they use a property of logarithms that says the ln of a minus the ln of b. This is from algebra, is the ln of A over B. Okay, so they want to call this 2 ln of 14 over 9. That's the answer they'll give you if you miss it. And if I typed 2 ln of 14 divided by 9 in my calculator, I would get the same thing, 88. So this is the answer they give. Some people like to do it that way. You can do either way. I just wanted to show you the property of logarithms, that you can't subtract your ln's. Just don't ever do that. And that'll come up again. Okay. All right, so let's look at an E problem, and then we'll look at a couple of B subs, and then I'll let y'all go look at the problems I have worked out. I'm working out. I mean, I'm just in the practice problems right now. The integral from 1 to 3 of 6 plus 3e to the 1.5x. Okay, so this is still a 6.1 problem. So this is 6x plus, that's rule 1, and this is rule 4 with the e's. It's 3e to the 1.5x, and we're going to divide by 1.5. Okay, so my antiderivative is 6x plus, now what I like to do that makes it easier number, I'll say, what's 3 divided by 1.5? 3 divided by 1.5 is 2. I mean, so it's easier for me to say 2e to the 1.5x. These are the same. If you want to write 3 divided by 1.5, that's fine. But if it makes a nice number, I just make it a 2. And now I'm going to evaluate it from 1 to 3, right? So I'm going to do f of 3 minus f of 1. I want to make sure you see how to use the E button on your calculator. All right, so I'm going to do my 3, store for x, and enter. Always do my top number first. Okay, and I type in my antiderivative, 6x, there's my x, plus 2, and the E is on the hard part of the ln, so it's second function ln, and it gives you 2e, and it blinks in the exponent. So that's where I put my 1.5x. And I put in, I get 198.034 minus the 1, store for x, and enter, and I go highlight my antiderivative, and push enter twice, and I get 14.963, and now I want to subtract them, so I go up and I highlight the 198, and I push enter, minus, and I go up and grab that 14 point, I push enter, enter, and now I get 183.070 or 071, so it's 183.07. So now you see why it's so important to use your antiderivatives. Okay, so that was the problem. That's your answer. So let's go check out a U sub. And there is a U sub song. It's what I like about you, but you don't want to do that. Okay. Let's do this one. The integral from 3 to 8 of 5 over 7x plus 6. All right, so this, you have to recognize that this is a U sub problem, because you can't have an x in the denominator, but when you move that x up, it's 5 times 7x plus 6 to the -1. Okay, so you have to move the whole quantity up. So this is a substitution problem. And it doesn't tell you. All right, so let me work the substitution. Substitution means you have a u, which is the inside, and you find the derivative of u, which is 7 with respect to x. Okay, so look what I do. It's hard to do this working problems. I always bring my constant term over, 5, and I know this is u to the -1. And I've got to substitute in for dx. Okay, so I'll look at my derivative. I have 7 dx. I just need dx, so I divide both sides by 7. So dx is du over 7. And so dx is just du over 7. So now I have this in terms of u. I'm going to integrate it. So when I add 1 to it, what happens? I get that 0. I can't divide by 0, so that tells me what? That's going to be 5 over 7 times the ln of u, right? Plus c, but we're not doing the plus c's. But don't forget, you have to put it back in terms of your original variable before you plug in, because this 3 and this 8 that they give you are with respect to x, not with respect to u, okay? So we put it back in terms of x, and I evaluate it from 3 to 8. And I'm going to just let my calculator do all the work. So I'm going to do 8, store for x, and enter. And sometimes when I have a fraction like this with the u sub, if you want to use this numerator over the denominator button, and you could put 5 ln of 7x plus 6, close your parenthesis, and on the bottom put 7. You could do it like that if you wanted to. You could do it like you've been doing it. I push enter, and I get 2.948, and I do 3, store for x, and enter, and I go up and I highlight my antiderivative, and I get 2.354, and then I let my calculator do the work. 2.94, enter, minus, there's my 2. And then I get 0.5937, which is 0.59. And you don't have to worry about the exact value. I'm going to get a couple more substitutions in, and okay. So let's see. Okay, so let's do -3 to 2 of 5x times x squared plus 1 cubed. Okay, it doesn't tell you to use substitution. That's the problem. You have to see that you have a quantity to a power. So this is a substitution. And what does that mean? That means you need u, and you've got to find your du, and you've got to substitute everything in. So let's write that again. -3 to 2, 5x times x squared plus 1 cubed dx. Okay, so we let u be the inside, and the derivative of u is 2x dx. Okay, so look what I do when I rewrite this. I'm going to always bring my constant term over. Remember, x is on one side, u's on the other. You can't mix up your x's and your u's. Okay, all right, so this is u cubed, right? So what's left over? X and dx are left over here. I've moved my 5, I've moved my u cubed. So let's look at that derivative. I need x dx. Well, I've got it if I just divide by 2. So du over 2 is x dx. Okay, so x times dx is just du at the end over 2. And now I'm ready to add 1 and divide. Okay, so we're going to add 1. So I bring over my 5 over 2 and u to the 4 divided by 4. And so when I rewrite this in terms of x, that's just 5 times x squared plus 1 to the 4th over 4 times 2 is 8. And I'm going to evaluate it from -3 to 2. So I'm going to say 2, store for x, and enter. I'll make sure I clear everything out because that's sometimes a disaster. So 2, store for x, and enter. I like to do my numerator over denominator. 5 parenthesis x squared plus 1 close to the 4th power over 8. Enter. And I got 3125 over 8. It just gave me that fraction. And let's do -3, store for x, and enter. And I go and I highlight that. And it gave me 6250. So look, I'm going to let my calculator, I'm going to go grab that 3125, there it is, minus the 6250, and I get negative 5859.375. So we're going to call that negative 5859, oops, negative 5859.38, right? Would that make a fraction? Sometimes it does. Nope, it didn't. So it made a decimal. So that's okay. I think the harder part of these is just writing everything in terms of U substitution and getting the dx down. So that'll just take a little practice. All right, the last one I'll do has an e in it, and then I'll let you have it. I promise. The integral from -1 to 3 of 8x e to the negative x squared plus 7 dx. So remember, the only thing that in 6.1 that we know how to integrate, if I can find my rules, is that e to the kx, right? I know how to integrate e to the kx. But I don't know how to integrate this e to the negative x squared. So that's where you have to recognize that you have to use your substitution here. Okay, so I can use this rule, number 4, when I have a constant times e to the kx. I just like the integral, if we did the integral of 3e to the 2x, I would just use 6.1 rule 4, right? And call that 3e to the 2x divided by 2. Okay, but I can't do that here because my exponent is other than kx. Does that make sense? Okay, so the steps for substitution, I always say move denominator up. We don't have a denominator. Pick u. So u is always the inside of the quantity, but if you don't have that, pick u to be the exponent on e. So we're going to get to the case where we have the integral of e to the u instead of u to a power. Okay, all right, so my u is negative x squared plus 7. My du is negative 2x dx, okay? So when I rewrite this, I'm bringing my 8 over, and that's e to the u. So what's left that I didn't write in terms of u? X dx. So, okay, there it is. I divide by negative 2, and I get x dx. There's x times dx is just du over negative 2. So it's du over negative 2. So now the integral of a constant times e to the u is just a constant times e to the u because you're just dividing by 1. So if you wanted to write that as the integral of negative 4 e to the u du, that would just be negative 4 e to the u plus c. And so my antiderivative with respect to x is negative 4e to the negative x squared plus 7. So this is where you got to be really careful, especially with the negative numbers. That's why letting the calculator do it is so important, okay? So I'm going to do 3 and store for x and enter. I'm going to type in my antiderivative, negative 4, and remember the e is second function ln. Let's use a parenthesis like they do, the negative x squared plus 7. And I close, and I get negative 0.5413. And this was just an example. And negative 1, I store for x, and I go up, and I highlight my antiderivative, and I get negative 1613.715. So I'll let my calculator do the work. I'd highlight the negative 0.54 minus the negative 1613. And so I get 1613.17. Okay. So that's a lot of U substitution. There's a few U substitution. There's some others. There's all 6.1 is the same thing. So I know you're now done with your test and you're going to try these. So hopefully that you'll have questions. And remember, I'll be around for questions, whatever you need me to do. And it's really important. So if you're stuck, just send me a text. Y'all all have my phone number, and or send me an email. Just try hard. You work hard, and then we're going to be able to take a breath over the weekend. So, okay, good luck. Let me know if you need any help, and I'll see y'all later.